So again, a rational number is a number that can be expressed as a fraction where a and b are integers. All right. And when you rationalize, you just take multiplying by the conjugate to get rid of the radical at the bottom. And that is how we're going to start rationalizing our numerators and denominators. Yes, I do post the recorded meets. Like I said, I like the quality of YouTube better because it allows for a higher resolution. The quality on Google Drive is very hit and miss, and Google Drive doesn't allow for subtitles, or if you want me to talk faster by playing with the speed, it doesn't allow for that, but it does allow for subtitles on YouTube, which is good. So I will be uploading this on our YouTube channel, well, a generic YouTube channel. So if you guys have any friends taking advanced functions this year, and if they need any extra help, like Anna already vouched for it, it was good for her. So just refer them to my YouTube channel, and then they can choose to listen or not listen to me. Like I said, I'm not the master at advanced functions, but I've taught it more than enough times to know what I'm talking about. Calculus, on the other hand, is something I will be working on to master this course as well. So hopefully by the end of this session, I will know this course like the back of my own hand, okay? And better than my fiance. That might be too much of a stretch, but it may be the case. So now when the denominator and numerator is one term, okay, what do we do to multiply any radical to get a rational number? For example, what do we need to multiply root a to get to a? So we have root a multiplied by a variable, let's say b, is equal to a. So now we have to ask ourselves, what is my value of b going to be, so that root a times another variable gives me a. So what would my unknown variable b have to be to get root a times a number or a variable is equal to a? Okay, there we go. So root of a. So this is true if root a times root a is equal to a, because root a times root a, if we were to write it in terms of exponents, what would it be? So when we have a square root of a number, what is the exponent automatically? Remember m over n, what would it be? A to the power of what? 1/2. So we have a to the 1/2 times a to the 1/2 is equal to a. So as we know, when we multiply exponents with the same base, we just have to add the exponents. So we have a to the power of 1/2 plus 1/2 is equal to a. We get a to the power of 2 over 2 is equal to a, which means a is equal to a, which means that root a has to be multiplied by root a to get just a in return. Okay, that would be a proof question. If I were to ever ask you to prove to me that something is true, you would have to use the theorems that we use in class to determine it to be true, or to help you prove that it is true. Okay, we're going to start with some easy rationalizing. So for the first one, we have 5 over root 3. So like I said, we have to multiply by its conjugate. So we're going to take root 3 over root 3. And that equals, again, multiply the numerators together. We get 5 root 3 over 3. And that is going to be my answer. Okay, so what I want you guys to do for around, this shouldn't take too long, so 2 to 4 minutes. I want you guys to try to do B, C, and D on your own. I'm going to ask, hopefully some of you participate, so I can ask some of you what you guys got. So if I don't answer your question, my apologies. Sometimes I scroll up and I forget to scroll down after. I wrote this part over here. Can you see this solution with the marker or not really? Okay. So what helps is if you pin me as the main screen, I'll appear big. So yeah. Okay. So again, we're doing B, C, and D, or you guys are doing it, and then some of you are going to share. I mean, I would like for some of you to at least unmute yourself. Some of my grade 9 kids do that, and I find they get more from the class instead of just typing out the answers. So if I have any social or extroverts in the class, feel free to unmute yourself. And by the way, it's okay to make mistakes. I don't judge you guys based off your mistakes. I'd rather you guys make a mistake and then learn from it. All right. So I'm pretty sure someone probably has done B already. So what would we do for question or example B? What would my steps be? What am I going to start off with? Anyone want to take a stab at this one? Okay, so it's okay. How do I pronounce your name?
It's Magdalene.
Magdalene, okay.
You can just call me Maj, it's easier.
Maj? Okay, Maj.
Yeah, Maj
Maj,
is
go for it.
way easier. So what I did first was I multiplied 4 and square root to the top, square root of 2 to the top and the bottom.
Okay.
And then after, 4 to the square root of, hold on, give me a second. I kind of skipped a few steps. So what I did was, so I did 1 in the square root of 2 is 2. Well, square root of 2.
So you and did then, so did you cancel out anything?
Just give me hold on.
Yeah, no worries. So we'll do it together, Madge. So you have 4 root 2 over 4 root 2, okay? What can I cancel out right away if you really wanted to? Because
the 4s.
Yeah, because they're going to cancel out anyways if you were to expand it regardless.
Okay, yeah, that's what I did.
So you get 1 times root 2, which you got.
Right, which is root 2.
And what'd you get for your denominator?
I got 8.
So you got 4 times 2,
which is 8,
equal to root 2 over 8. All right, perfect. Thank you, Madge. I know it's a bit nerve-wracking speaking in front of the class, even though you don't really see them. But you know what? That's how life is. You guys are going to have to learn how to talk to people or even, give presentations. I was never a really vocal or extroverted person in high school or even in university. Teachers college kind of forced me to be more, outspoken as a teacher, only because I'm in charge of your guys' education. I want you guys to be successful. And I always tell my students, I want you to strive to be successful. And if you are richer than me, it is what it is. I would rather you guys be successful and richer than me, because that way I know that you guys learn something from me, not in terms of calculus, but in terms of how to apply the skills in class and what you learned throughout high school into your everyday life, okay? They all know I give some motivational speeches sometimes. It's just who I am. I just want you guys to know that, yes, this is calculus, but it's also a way for you guys to learn how to work together as a class. And just by communicating with each other and communicating to the class, showing your solutions, it just gets you out of your comfort zone and makes you become a more confident person. So does anybody want to do example 1C? Is the 4 necessary to write? Like I said, you would have to write it down just to show that you're canceling, but you don't really have to show it as long as you know that they cancel out and as long as you don't mess up the answer. Okay, so you can skip that step, but as long as you get the final answer to be the same, that's completely fine with me. If you skip steps, just know that if you do happen to get the wrong answer, it may be harder for me to look for partial marks when it comes to your assessments. So does anybody want to do example 1C? We got Madge. Okay. You're gonna have to help me pronounce your name.
Priyanshu.
Okay, Priyanshu. Is there a nickname I can call you or no?
I've never really had a nickname.
Okay, Priyanshu. I'll probably remember that. All right. So
okay.
What do we do?
So I might be wrong, but I'm going to try my best here.
Okay, that's fine.
I multiplied by square root 5 over square root 5.
Okay.
And I got negative 20 square root 15 over 5.
All right. So remember, like fractions, we can simplify this even more. So Priyanshu, what can we simplify in this case? Look at the coefficients in front of, look at the 20 and the 5. Can we simplify that?
Negative 4 square root 15.
So negative 4 root 5. So that would be your final answer. Okay.
Oh, so you'd put it, you'd divide the.
Yeah,
Where did you get the
so
square
you
root
can,
5
you
from?
can simplify the coefficients in front of the radicals, but if there's no radical at the bottom, you cannot simplify another radical.
Well, just a quick question. Where did you get the square root 5 from, and how did you get rid of the square root 15?
Because root 3 times root 5, right? When you have two radicals together, you multiply the
But
numbers.
in your answer, you have negative 4 square root 5. I'm confused where the square root 5 came from in your final answer.
15. Whoops, I missed the number.
Oh, that's what I was confused about.
Yeah,
Okay.
my bad. I missed the number. Sometimes I get ahead of myself. And yeah, sorry, Leanne, my mistake. And sorry, Ian, my mistake. Like I said, you can call me out on my mistakes. I do make mistakes sometimes. I'm not perfect. But that also doesn't really affect my ego. If I'm wrong, I'm wrong. I'd rather you guys tell me I'm wrong than you guys say that's square root 5, and then on a test you follow that, and then you get it wrong. And last but not least, question 1D.
So are we supposed to simplify for D, like from the beginning, or do we have to do that at the end?
Do it at the end. But if you want to cancel out the 2's, feel free to cancel out the 2's right away. Okay, so what would we do for D? So if I were to say, okay, you don't have to show me the cancellation, what would be the answer for D? So if I were to just simplify right away, what would I do? Anyone? It's exactly the same thing as B. Okay, Lauren?
Would you multiply it by root 6 over root 6?
Yep. So automatically, we can cancel those right away. You don't have to show the cancellation because we've been used to it. So the reason why there's no need to write the 2 as a coefficient is because it's just going to cancel out in the numerator and the denominator. So there's really no need to have that 2 in front of the root 6 anymore because it's a common factor between the numerator and denominator. So Lauren, what do we do next?
So then from there, it would be root 90 over 2 times 6. So root 90 over 12.
Yep. Perfect. Are we done? Can we simplify the radical?
I'm honestly not sure.
Okay, so what I mean by simplifying the radical is can we multiply two numbers to get to 90 where one of those numbers has a perfect square root? Does anyone want to share that answer? So what numbers multiply to give us 90 and one of them has exactly a perfect square root? Anna, thank you. We have 9 and 10, 9 times 10. Madge, were you going to say the same thing?
I was just gonna ask, does it matter if we simplify in the beginning instead? So
like right here?
no, so the square root of 15 over 2 and the square root of 6, you can simplify that, can't you?
Square root of 15 and 2 over 2 root 6. You can simplify right away.
Yeah.
Also, show me.
Okay, so the 15 and the 6 can be, hold on. Wait, let me think about this and come back to it.
Okay, no worries. Can anyone give me two numbers that multiply to 90, one of them having a perfect square root? Priyanshu?
You got it right. I don't know if this is the most effective one to use, but I did 9 times 10, and 9 is the perfect square root for 3.
Yep, 9 times 10 over 12, which is equal to square root of 9, which is 3, times root 10 over 12. And what happens to the 3 and the 12? I think Anna gave us the answer already. So this cancels out. So this becomes 1, and this becomes 4. So our final answer, I hate running out of space, is going to be root 10 over 4. Okay, so Madge, I can see why you would simplify at the beginning. You can. Did you figure it out?
Yeah, so I divided 15 by 3 and then 6 by 3, which gave me square or something else.
So you got root 3 times root 5 over 2 times root 3 over root 2. So what would cancel out in that case?
Sorry, I can't really see the board. Is it the 3's that cancel out?
Yeah, the root 3's cancel out. So we're left with root 5 over 2 root 2. So what would be multiplied by if we wanted to simplify?
Root 2.
Root 2.
Yeah.
And that would give us root 10 over 4. So there's two ways to do it. Madge suggested that we simplify at the beginning. That's completely fine. Or we can do it the longer way, where we don't simplify right away. As you can see, both of them give the same answer, so I don't really care what you do. You simplify right away or not. As long as you get root 10 over 4, that is perfectly fine with me. So the good thing about these videos is that you don't really have to copy if you don't want to. You can copy at the end as you watch it, but I'm going to give you guys a minute or two to just copy these solutions down. Yes, Lauren.
Sorry, I can't see the board for like the last part of D. Could you move the screen a little bit to the right? Thank you. That's a lot better.
I may have to just move this back. Tell me when to stop.
That looks good.
Okay. Like I said, this won't be a problem as of Thursday. So are you guys refreshed? Is this pretty easy? How are you guys feeling about rationalizing so far? Good so far, okay, perfect. Guys, I recently watched The Wolf of Wall Street on the weekend. Yeah, Jordan Belfort is an interesting man. Have any of you guys watched The Wolf of Wall Street?
Wait, did you watch it when it came out on Netflix?
Yeah, they had it on and then they took it off and then they brought it back on. So I watched it over the weekend. Let's just say, yeah, he's an interesting. He's a smart guy, but he's also scum. That's what he is. I don't know if you guys agree with that statement. But he does know how to talk, and I can give him that. Okay, so I'm going to erase this. Like I said, this will be posted online, so don't be sad that I'm erasing this already. All right, I'm gonna move down. All right, so when the denominator or numerator is a two-term expression, so a binomial, this is when the case we can rationalize the denominator by multiplying by its conjugate. So an expression such as root of a plus root of b has the conjugate of root a minus b, and an expression such as negative root a plus root b could have a conjugate of negative root a minus root b or root b plus a. Why does it make sense that when these two expressions are multiplied together, they will produce a rational result? Okay, so think about back in advanced functions about the different types of factoring, okay? So let's just say if I had this written down, this will probably help you guys come up with the answer. So if I have square root of a plus the square root of b, and I multiply by its conjugate, which is root a minus root b, why does it make sense that you get a rational as a result? What factoring method does this look like when it's factored out? It's a something of squares. Let's see if you guys can notice it. Nope, not a perfect square. It's a difference of squares, okay? Because when we multiply everything back in, we get a plus root a times root b, so root ab minus root ab minus b, okay? And as you can see, these two cancel out, which is the property of the difference of squares, and we're left with a minus b, where a and b are both rational. So that is again an example of a So remember, this is, so when you see this is its conjugate, root a minus root b. If we have negative a plus root b, we can have a conjugate of negative a minus root b or root b plus a. Okay, so when you see this one first in the denominator, to multiply by its conjugate, you're going to use this. if you see this guy in the denominator, you're going to use one of these two as its conjugate. So now with that said, we are going to move forward and get some examples that have to do with the conjugate. Also, if I'm going too fast, feel free to let me know if I'm going too fast, because I may talk fast at times, or if I breeze through an example, just let me know. So the first one is we want to simplify the following by rationalizing the denominator. Okay? So the first one is -2 over root 2 plus root 3. So in this case here, we have our original as root a plus root b. So what would my conjugate be? We did it on the last slide, or the last question. What would my conjugate for root 2 plus root 3 be? Root a minus root b. So our conjugate is root 2 minus root 3 and root 2 minus root 3. The reason why root 2 minus root 3 is the conjugate is because when we multiply these guys, we're not going to have a middle term, okay? We are just going to have whole numbers that we can add or subtract from each other, which is why the conjugate helps us rationalize the denominator. So I'm going to do this a long way, just so you guys can see what's going on. So let's just say I put brackets here and brackets here. So I'm going to multiply my numerator together. So what is going to happen is negative root 2 multiplies to root 2, and negative 2 also multiplies to root 3. So we're going to get negative 2 times root 2, which is negative 2 root 2, negative 2 times negative root 3, which gives us positive 2 root 3, because two negatives multiplied by each other gives us a positive, okay? And now this is where the important part comes in. I'm going to do this once. I'm going to do it the long way so that you guys understand. So for our conjugate, we're basically just going to FOIL. So root 2 times root 2, root 2 times negative root 3, and then we have root 3 times root 2, and root 3 times negative root 3. So for the first one, root 2 times root 2, what does that give us? Root 2 times root 2. It's going to give us 2. So we have 2 as our first term. Now root 2 times negative root 3, what does that give us? Negative root 6, okay? Perfect. Now we have positive root 3 times positive root 2. That would give us what? Positive root 6, thank you, Priyanshu, Ian, and Anna. So positive root 6. And what's root 3 times negative root 3? Negative 3. So I'm doing this slowly because some of you are confused. So the reason why this conjugate works is because we don't want this middle term, okay? We want a whole number to be in our denominator. So we're going to be left with negative 2 root 2 plus 2 root 3 over 2 minus 3, which is equal to negative 2 root 2 plus 2 root 3 over negative 1. Okay, so we can simplify this even more. Can I factor out a number from the numerator? Okay, Ian, are we gonna factor out positive or negative root 2? Because we usually like the first, what's it called? The first term to be positive. Okay, we're gonna take negative root 2, bracket root 2 is left over, minus root 3, over negative 1. The negatives cancel out. So we are just left with 2 times root 2 minus root 3. Or if you left it expanded, that's fine. Either answer works. Any questions before we take our break? So like I said, I did this a long way so you can see why the conjugate plays an important role when rationalizing. So are we good? Thumbs up, thumbs down. All right. So we're going to take a break from now until 7:50, and then we will continue the rest of the lesson. I think we're only going to get through 2 lessons today, but we'll see how it pans out. Okay, so take a break, be back at 7:50. Try not to log off.